Let's go again. We have 3 words: translation, /shift. We have reflection, /flip, and we have dilation. Thank you. Stretch. Okay, so we said a translation, if it's attached, we go left and right in the opposite direction. That's the same for absolutely any function in the world. That's why it's F of. F means any function. It's not specific. Up and down, same direction. If it was not attached to your X. All good? Then we had reflection. We said if it was a negative f of x, it is obviously about the x-axis, and which makes sense because I think of a parabola for that one. If it's f of negative x, it is about the y-axis. Again, which makes sense because you're flipping it. All your positive x's become negative x's, your negative x's become positive. That's how I see it. So again, that makes sense. All good? Dilation, which is very poorly done. That's the one that everyone gets very confused about. In year 11, I would have said don't worry about it because you didn't need to worry about it. In year 12, you still don't need to worry about it, but what happens is because they're going to give you a function now, any function, and they're going to actually dilate it, you do need to know what the dilation is doing. That's all. Whereas before, we never worried about it. So I'll show you it. I've made you guys a nice little assignment for this as well, which you can do. It'll take you about an hour, and that's pretty much this whole topic done. So dilation, just so you can understand it better. But dilation, there are 2 words: vertical dilation, vertical dilation, and horizontal dilation. Can you help us out? Vertical dilation. Yes, stretch the y value, so it's going to be, is it a times f of x or f of ax? You are correct. Vertical dilation, it is multiplied to, yeah, I'll be right. Whoever calls, I'll pick up. Is that okay?
No.
Why? Vertical dilation, a of f of x. Horizontal dilation, f of ax. So far, so good? So vertical, as you guys should know, especially with your algebra, it is multiplying to the whole function, which means the y value is actually changing, which is why it's a vertical dilation. It's stretching up and down. Horizontal dilation will be stretching left and right. Sounds good? And you can see why, like me personally, someone like me, I just go, well, that A is attached to the whole Y value, whereas that A is only attached to the X value. So that's how I think of it. There is a little disclaimer. For vertical dilations, it is a scale factor of A, whereas this one is a scale factor of, what do we reckon? 1 on A. Very good. And that is pretty much it. It's just time to do some questions. So let's just do a really hard question in inverted commas. Like I went through 3 papers just with the previous class. We went through James Riss, Hunters Hill, and Blacktown Boys. All 3 didn't have it. Didn't have any of this topic. The HSC did. It was transforming circles by just moving a left and right. So there was no dilations in there, which means in your course, I think in your HSC, there will probably be a dilation question in your HSC.
Wouldn't a circle be?
But a circle cannot be a dilation, you tell me. Because then it's no longer a circle, it becomes an ellipse.
So you make an ellipse by dilating the circle? Or
Yeah. A circle, it looks like, an ellipse is this. X squared on 4 plus y squared on 9 equals to 1. So they're not technically at the center anymore.
yeah.
So X is moving a little bit, stretching differently, Y is stretching a little bit differently. That's an ellipse. Anyways, although you need to worry about it because the ellipse is completely gone. It was part of 4 unit, but that's even gone now. So you won't even need to worry about it. Anyways, let's look at a question. Here's my question. I think this is a hard one, right? So if you can understand this one, then the easier ones are nothing. But this is probably the hardest style of question. If you see them around, you probably want to do these ones more than just move this left and right and up and down. Those are nothing. So here's a parabola. Here is a transformed version of that parabola. Correct? All good so far? So this is g of x, which is k f of x plus b plus c. And let's just change this y so that we can keep it consistent. We'll make it f of x for you guys. How many of you guys have seen like this? I think you have. We did that. You've seen questions like that? I hope. Like if your teacher's giving you one of these, well, then you're going to get it in your exam. That's the first time you'll see it. So here we go. Tell me, you've got a parabola. What do you want me to do for it to get to eventually here?
-5 is the y-intercept. Like, so c would be -5.
Incorrect. You are wrong.
You start with the brackets.
Yeah, I would have said that, but I think you definitely x plus 1, x shifted down 3. You're wrong with that thinking. Be careful. Y-intercepts at -5. The parabola is shifting down. If I had a parabola here, there it is. If I shifted down 5, it'll be down here. Careful with that thinking. But you had the right idea. So you said x plus 1. You said start with the brackets. It's pretty much the same thing. So I'm going to go with, it doesn't matter. G of x equals k f of x plus 1. Let's just do that for now. Squared. We're okay with that? Then, so that means we're here somewhere now. Then, -3. We're here now. So now we're down here. Now, minus k. I like that you said minus k. It's not -1, because if you said -1, that means you're specifically assuming it'll look like this. How do you know it's going to go through -5? You don't know that. So it's still going to be k. You don't know its stretch. Ooh, no. -1 and -3 is incorrect, because that will -1, -3 will definitely work, because you made it work. Right, you said x plus 1 squared minus 3. You don't sub in that one. Sub in x is 0, y is -5. Sub in y equals to -5, negative k, f of x plus 1, all squared, which is x plus 1. What, did I just square this? What am I doing? It's f of x plus 1. F of x plus 1 is x plus 1 squared. So sorry, x plus 1 squared minus 3. That's better. X is 0 plus the 3, and I think you guys can see k becomes 2. So therefore, what has happened is this. Or yeah, the transformed version is this of the original. Now, yes, we're okay with that? One little bit that I have to make sure you are very careful with. Let's say maybe in a multiple choice or something like that. I accepted it because mathematically, if you're doing it like this, it's allowed. If you're doing it like this. Technically, the way you're saying it is wrong though. So what you said was wrong. And I'll tell you why what you said is wrong. And I hope you guys remember this when you actually have to explain it. Because if you go through the steps you said, it's actually wrong. Watch. You guys had said, start with your parabola. I agreed. You said move to the left. Oh, no, yeah, you said move to the left. I wrote that, f of x plus 1. You said go down 3. I did that. That was minus 3. That was fine. Then you said put a minus k. I did that. But that minus k, you got to understand there is no such thing as, hey, just go make this k into a minus k. What are you actually doing? You're multiplying this whole function by a negative 1. So what happens to minus 3 all of a sudden? It becomes a plus 3, which means your order of transformation was wrong. So if it was a multiple choice that do that and you went for that one, you're wrong. Your transformation is wrong. So what should have actually happened? What's the proper way of transforming? What should have happened now that you realize the problem? Flip it down first, then move to the left or move down. It doesn't matter after that. Move it to the left, then move it down. Because then the negative is not going to impact my y value here. Do you guys get that? Everybody? You sure? Because you got to make sure if it's attached to the in front, let me just scroll up for a second. See, if it's attached to the front, the whole function is going to get multiplied. Careful with that. Okay. Well, that's a really hard one. Now I'll bring the dilations in as well, just to show you how those work. And if you guys are happy with that, done. Let's do an easy one first with a point. If you can get the point, we'll do a function. If you get the function, this topic's finished. We'll just do trigs after that. Just practice. You just got to practice it. All right, pick a point. Who wants to give me a point? 2, 5. Let's go with that. 2, 5. Give me some things you want me to do to them. We'll do 1, 2, 3, 4. Give me 1. What do you want me to do to it?
Move
Yeah.
it down.
Move down. 4. Next, Ben.
Move to the right.
Right 2. No, let's not do that up. Let's not do up and let's not do up and left and right. What else is there? There's the other 2 stuff. Flip, so reflect. Let's flip. Where do you want to flip? Down, you said? So flip about the x-axis. And then stretch it now. Dilate, horizontal or vertical?
Choose horizontal.
It's good, you chose the harder one. Horizontal dilation. Why did I say the harder one? What do we multiply horizontals by? 1 on A. You got to remember horizontals 1 on A. Okay, let's do it. So wait, horizontal, is it x-axis or y-axis? X-axis. Horizontals, x-axis. So where was I going with that? I don't know, but just remember horizontals, x-axis. So if it says dilated x-axis, you know it's horizontal, which means 1 on A. Dilated y-axis, that means vertical, just A. Okay, continue. Part 1. Down 4. 1, 2, 3, 4. That's at 2 and 1. All good? We'll label that as A. That's going to be labeled as A. Go right 2 units. 1, 2. That's at 4. That's B, which is at 2 and 3. B. Flip x-axis. So that means my 2 should still be a 2, and my y value becomes? Flip about the, sorry, wait, what am I doing? Oh, sorry. Thank you. I'm thinking of too many things at the same time. X is 4, my y value is 1. Thank you. and then flip about the x-axis, we're here. My y value should be -1, my x value should be the same. We're going to call that C for -1. Still good? And then it's a horizontal dilation. Oh, you didn't say of how much? Of
18.
18, which means we're going to get C at 4 on 18 and -1. So D is now 4 on 18 and -1. Do we get that? You sure?
Yeah.
Anyone confused? 4 on 18, because obviously it was 1 on 8. You sure? No one's got any questions? Okay. We're going to do it again for a function now. So give me a function. Y equals, up to you, any function. Y equals, that's an easy one. Go harder. Try whatever you think is, like when you see it in your exam, you're going to be like, whoa.
X power 5.
Just x power 5? Oh,
Relax, yeah.
okay. X to the power of 5,
Plus x power 3
x cubed
on.
on.
No, just a cube.
Yeah, let's do it. I think on's good.
Just an x cube.
Oh, okay. No, it's silly. On? Yeah, yeah.
You want it to be
On.
I don't know, some of us take away.
On. I'll put trig in there. On sine. It doesn't matter. It doesn't matter. Sine x. That's it. Let's just do that. Now.
Plus 12.
Plus 12.
No, plus 12 at the end.
That's a drag.
You know what's a drag? You know what's a drag?
Okay. 1, 2, 3, 4. Shh. Don't be jealous. 4. 1. Tell me, what do you want? I think let's do the first two as a dilation. So we're just so we can get that out of the way. Vertical stretch or dilation of 7, and then a horizontal one. Horizontal dilation of -2. Let's just see what that does.
Ooh.
And then 3, we're going to shift up to 4 left by 3 by pi, whatever. Okay, that's it. That's a stupid question, but at least you get to see it done. Now, let's see. All right, vertical stretch. What does a vertical stretch do? That changes my x's for 7 x's. Do we agree with that? So all my x's become now 7x.
Does that measure sine as well?
No.
Sine or sine? No.
Sine.
Oh yeah, all my x's become 7x.
Oh, yeah.
So sine becomes sine 7x.
Yeah.
Right?
Yeah.
You get why? But because all the x's are changing to 7x. Yeah. So maybe I'll change that to f of x. So if 1, you're doing this. You're doing f of 7x. And that becomes, let's call it g of x. So that equals to 7x to the power of 5 plus 7x to the power of 3 on sine 7x plus 12. Easy? Then 2. Horizontal dilation of -2. That means you're going to... No. Something's wrong. Vertical should have been 7. Come on, see how simple you can make a mistake there? Vertical should have been y values are multiplying by 7. That's wrong. That is wrong. How quick is it that you can make a mistake? 7. So you know what I would do, and I did this when I was doing this year's HSC paper. I was writing my solutions. The first thing I did, I would have straight away written here, vertical stretch or vertical dilation, A, G of X, horizontal, G of AX. And then right here, I would write 1 on A. Because it's so quick you can make a mistake with those two. Anyways, let's start it again. G of X equals 7 times this number, 7x5 plus 7x cubed. You don't multiply the sign by 7. Do you know why? You don't multiply the sign by 7? Because, say it again. You said it. Because it's in the denominator. If I multiply the denominator by 7, what's going to happen to all the 7s? That's a good one. So it's good that you said a fraction. So be careful with that. You're only multiplying the top, and that's it. Just the numerator. 7 times. Yep. Okay. Number 2. Number 2 is h of x, which equals to g of negative 2x. Correct? But what do I actually sub in? Negative 2. Yeah, that's why you see me writing that. It's g of ax, but you're actually subbing in 1 on a. So it's going to look like this. H of x becomes 7 x to the 5 x on negative 2 to the 5 plus 7 x to the negative 2 on negative 2 cubed on sine x on negative 2 plus 84. You can see my y value didn't change there. Sorry?
It's actually the x's that change, not the whole thing.
Yeah, of course. Like let's again, you should see why that happens. Here, you're timesing the whole function by a. With this one, you're replacing your x's for ax, but it's not really ax, is it? It's 1 on a. 1 on a. That's okay.
So if it was 5 on x.
5 on. If it said 5 on x, you're replacing x for x on 2. So it should become 10 on x now. Does that make sense? Yeah. You replace it you're keeping your x still there, right? So it's just going to be x on 2 instead of it being 2x. That's it. Okay. Make sense? Everybody? Okay. That's it. That's hx. Shift it up to number 3. Shift it up by 2. I really don't want to rewrite this. So I think we can all agree that becomes 86. That's number 3. And then left by pi. I'll do that one. Number 4. So this is the whole transformation now. We'll call it L of x equals left by pi. That means instead of it being x, the x goes to the left by pi. That means plus pi. So 7 x plus pi. Oh, hold on. Hold on. X on negative 2. The x is replacing for x plus pi. X plus pi. X on negative 2. It is x on negative 2. It is negative half of x. Yeah, that was wrong. That was wrong. So just let me show you what is very tempting to write. X plus pi on negative 2. Very tempting to write. You got to be honest with it.
It'd be x minus negative 2. Because you have to bring it over, right?
What do you mean?
As in, to put the pi in, to move by that, it would have to be a shift to the that side, so to the negative side.
The answer is still that.
Oh.
Hold on. It's tempting to write that, but you've got to be careful with what it's being multiplied by. Just like the one before when you said, okay, make it into a negative, you can't just go and put things in when there's other things attached to it. So you've got to be very careful with that. I just want to show you why in this case it's okay, but you've got to be careful with this. Look, negative half x. If I'm replacing x for x plus pi, as long as I've got my negative half attached to both of them, it's fine, which is what I had written anyways. But so you've got to be careful. That pi is actually attached to the half as well. Make sense? Because the x plus pi, it gets replaced for x. So yeah, that whole thing's to the power of 5 plus 7, and then I'll just write this the proper way. But I was just saying it's not good enough for you just to think, oh yeah, I can replace x for x plus pi, because I'm sure I can give you a few trig ones that just don't work like that. So you've got to be careful with that. Over sine x plus pi on negative 2 plus 86. We're happy? We get this topic? You think so? I hope so.
Now, how to sketch it?
Yeah, exactly. Transformations or graphing functions. How do you sketch this? A nice program called Desmos, and then you just dive it all up and see what it gives you. That's a good one. Yeah, well, look, it's a really bad function because it's divided by a trig, and trig is an oscillating function. So, and the other one is an infinite function. So we'll plug it in and see what